To figure out which statement could be the width of the border, we will consider each statement separately. Before we do that, let's go ahead and draw a diagram of the image that they're talking about. We have a square patch from a quilt as a square interior, a square interior surrounded by a border of uniform width. So let's go ahead and let's draw an image and give some variable names to these lengths that we're going to be dealing with. That way we can refer to them without having to use words. So drawing up our square, let's go ahead and let's call this width, the width of the border, W. And that means that we can also call this W. And then let's go ahead and let's call the entire length of the square here. Let's call that X. That means that this distance inside, all of these lengths, since they're square, are going to be X minus 2W. Since each distance on the side is 2W, so we have a total of X, minus 2W will leave us with the edge of the square inside. Now, additionally, we're talking about areas in the question. So let's go ahead and let's call the area of the interior is going to be the area of the inside portion. And then we'll also use area of the border. That way we can tell the difference between the areas that we're talking about. So the area of the interior will be the area of the interior of the square, and the area of the border will be the outside portion here. Since the area of the square is length times width, that would be the inner portion, and the outer portion, we have the following equation when we consider the given ratio in the question, the ratio of the areas. So setting up our ratio of areas, the area of the interior of the quilt divided by the area of the border of the quilt is a ratio of 100 to 44. Now, using our variables that we have in our picture, let's scroll down a little bit so that we have some space, we can actually plug in for these area values. The area of the interior will be our X minus 2W times X minus 2W, since this is a square and all the sides are the same. So we have X minus 2W squared divided by, it's a wonky division symbol, so let's fix that, divided by the area of the border, which would be X squared, so the area of the entire quilt, minus the area of the inside portion, would leave us with the area of the border, so minus X minus 2W squared. Let's extend that so we don't forget it's all over that. And equals, we can simplify 100 over 44, leaving us with 25 over 11. We can actually simplify this a little bit more if we go ahead and cross multiply and distribute the 25. So this would leave us with 11 times X minus 2W squared equals 25X squared minus 25 times X minus 2W squared. If we notice on the left and right hand sides, we actually have similar like terms. So we can move this term to the other side and combine our like terms here. We end up with a 36 times X minus 2W squared equals 25X squared. We can simplify a little bit further by taking the square root of both sides. Taking the square root of both sides, we have 6 times X minus 2W will equal 5 times X. Now, distributing our 6 and isolating our X, we end up with 6X minus 12W equals 5X. So X is equal to 12W. Since there are no constraints on the value of X, any positive value of W could be the width of the border. Then we would just have x dependent on that value to adhere to the given ratio of areas. There's no need to consider each statement separately since all positive w's will work, and all of our statements, if we scroll back up, all of our statements are actually positive. So since any positive width will do, since any positive w will work or could be true to adhere to the requirements, all of these statements could be true. And our final answer choice would be answer choice E. And we could eliminate all of the other answer choices because we know all of the statements must be true.